David Brown from the Interactive System Research Group of Nottingham Trent University. So I would like to give the floor to Lindsay. Thank you.
Okay, everybody, I'm going to start. It's David Brown. I'm going to start to the first couple of slides. So what we're talking about is the Interactive Systems Research Group in the Department of Computing and Technology at Nottingham Trent. This is a background. We have 9 academics, research associates, and research fellows, PhD students. We're looking at design coping with human diversity and social inclusion. We always target users in the design process, as I'm sure all of you do as well, very much in order to tackle some of the high levels of abandonment of assistive technology, and other people have talked about why that might happen too. One of our prime goals is a bit like SETI really. We're always searching for signs of alien life. We're always looking to evaluate absolutely everything we do. We do lots of work on serious games, game mods, extensions of smartphones, Android apps. And what we're doing is always looking to extend by inclusive design the use of everyday objects and technology that doesn't mark people out with disabilities as being other or different or separate. We have been working with a number of universities. We've just been involved in a big ESRC study, which is a big Research Council funded study in the UK. We produced a taxonomy for assistive technology. And rather than splitting assistive technology by form, we're doing it by usage. So the first category is technology that uses to train or practice, technologies that assist learning, and technologies that enable learning. We've drawn out quite a number of themes from this 3-year literature review as being important. User involvement is highly important, and a number of significant projects have acknowledged this, and as we're saying before, designing on the types of devices people want to use and tackling high abandonment rates. There's a high degree of mobile mainstream devices used, and the rapid deployment and popular acceptance of mobile phones, particularly the smartphone and other personal digital assistants, has led to a bit understandable demand for digital assistive technologies to be mediated through the use of these devices. We're also really experiencing a high degree of visibility all of a sudden of AT. They're becoming much more visible, particularly as a result of move of synthesis, speech recognition, graphic symbols into mainstream and inclusive settings. We're also looking a great deal at interaction and collaboration, which research focuses on interaction between people with disabilities. But a lot of research now also includes interaction with those identified as not having disabilities, which is an important move. Developing interface and technologies is very important. As we're seeing many people, we come on to this a bit later on, presenting in our special schools with profound and multiple disabilities due to the proximity of very good teaching hospitals with high degrees of neonatal survival rates. So we have to work very much harder on terms of interface devices, including BCIs, brain control, gesture control, eye gaze, and very much robot-mediated interaction and learning. And as I said before, our main approach is inclusive design. One of our primary uses of software, extending the use of software, is creating games mods. So we look at popular games engines, such as, I'm sure you all play them, Half-Life 2, Unreal Development Kit. And we extend their use to make them accessible for people with disabilities. There's a high prevalence of ID in the UK. 4 to 5 per thousand have a mild or moderate learning disability, severe learning disability, 1 in 25 have a moderate learning disability. And UK government reports highlight the need to teach communicational and independent living skills to these people. And serious games allow people to take charge of their own learning. They enjoy the repetition that these games offer and the gradual increase in level of challenge. They allow people to work at their own pace and make mistakes without those being levied in painful and damaging ways. And they give access to education opportunities and experiences and engagement with knowledge and people. And for once, they give people with disabilities, especially intellectual disability, some active control over the learning process and some degree of control over the learning process, which is important for a group of people who are often viewed as being passive. But it's no use doing any of this work unless we prove the efficacy of our approaches. I'm not going to go into too much detail here, but we've had 4 controlled studies recently published that serious games can have a positive effect on choice reaction time, independent decision making, working memory, and functional skills for people with ID intellectual disability. We recognize this is an extremely heterogeneous population. So what we use is a matched pairs design here, where we match the pairs by assigning half the group into an intervention group, which is what we're trying to measure, the effect of that intervention piece of assistive technology, and half into a control group. And we match them on performance for a given variable. So that allows us to say, after repeated intervention after baseline measures, we can say that any difference between the 2 groups is entirely due to the intervention software and not differences between the groups. So we have a study now of 16 key stage children, matched pairs design, and they all experience 5 20-minute weekly sessions using these 2 pieces of software. So the first group used on the previous page Cheese Factory, which is a game to develop fractions, percentages, and decimals, and the other one was just a space shape naming game. So a good control there. We're controlling everything. It's just one game teaches the mathematical skills, and the other game, equally engaging, which is teaches shape recognition and naming. So we took 2 baseline measures, paper-based. The top one you can see is challenges students to fill in the missing part of the whole shape on the left-hand side with one of 3 shapes placed on a grid. And we have 5 increasingly complex examples, and we ask the students, and we record the number of correct answers we get from the students. The second test moves to fractional notation, where you're asking the students to match the fraction in the square, again with a grid of fractions on the right-hand side, and we're asking them to do that 5 times, and again recording the percentages of correct answers. So we take a baseline test at the beginning, 2 baseline tests. Then we have the intervention software to teach math skills, a game to teach math skills, and the control group to teach just naming of shapes. And then we retake these baseline skills. What we found is that the intervention group has significantly improved their functional skills using the Wilcoxon ranks test, whereas the control group did not. We also have a similar positive evidence for other the elements of choice reaction time, independent decision making, and working memory, all for people with intellectual disabilities. That's our prime focus to prove the efficacy of these approaches. One of our other major applications of assistive technology using games technology is stroke rehabilitation, which currently affects 15 million people annually worldwide, of which 5 million people are left with some permanent form of disability, commonly affecting the upper arm and shoulder. One of the problems is, in order to recover from stroke, people must make very soon after stroke early, intensive, and task-based exercises. And one of the barriers to that is that most current stroke rehabilitation systems relatively sophisticated and or expensive hardware, and it's often hospital-based. So what we're simply trying to do is, can these benefits from these really expensive systems be obtained by less affordable gaming systems? And our commercial gaming systems offer important advantages such as mass acceptability, direct feedback to the user, and most importantly, affordability for unrestricted home use. People can practice on a quotidian basis at home and not have to go into a hospital. We have two systems in development. The top one, which you can see kind of like the glove there, is the Wiimote system. We have two cameras, two Wiimotes pointed in towards the user at 20 degrees. The cameras on those Wiimotes track the position of four sensors placed on the patient's fingertips. And these infrared emitting diodes can be tracked. We can work out a three-dimensional position, and these can be put back onto game responses. We also have a markerless system using thermal cameras, a bit more expensive, which uses thermal tracking to do the 3D positioning and gesture recognition using skin color histograms and skin temperature thresholds as standard algorithm. These games, we've developed 4 games. You can see one on the bottom diagram. But the games crucially elicit the types of movements people have to make post-stroke. And these have all been worked out with clinicians at local hospitals. This is undergoing a large, we think the largest worldwide study so far, a randomized controlled trial of 60 patients aged 18 to 85 years old. And the intervention group used the glove and the software, and the control group received normal care, and we're in the middle of that study. We work very closely with local schools. One of them is involved in the AGES project, where we're looking at least 20 pieces of assistive technology and assessing them specifically with younger students with severe intellectual disability, but also compound multiple physical and sensory impairments. What we're finding and since I've been at the school, which is 15 years of research, is that young people are coming through with much more complex physical and compound sensory disabilities due to higher and much better neonatal care at local schools. So we always have to work harder in order to develop new input modalities for these students. We have a methodology when assessing this assistive technology, which looks and records at usage of assistive technology. We divide the problems into their physical ability, have they got sufficient strength to operate the device, their cognitive understanding, are they constantly pressing the wrong buttons, they don't understand what to do. Device construction, we've had some really great joysticks, but they're very light and the students just pick them up. Or the design of the environments themselves, are they sufficiently able to navigate around these environments without bumping into walls and doors? Of particular interest at the moment, we have 2 studies at the Oakfield School going on, is looking at brain control interfaces. Particularly interested in the emotive epoch, which is a 14-channel, you will probably all know this, neuro acquisition and processing wireless headset. It measures conscious thoughts, forwards, backwards, left, right, emotions apparently, also brain to muscle signals like winking or moving your eyebrow, but also it measures head rotation. It has a 2-axis gyro. So we're currently assessing that at the Oakfield School as well. Current projects involve working with Dasher, which you all know is a zooming device for AAC, with students with severe motor disabilities. Working out whether they can control Dasher using brain control interfaces such as EPOC. We also have iPhone-controlled robotic mediated learning interactions for children with cognitive disabilities, especially teaching communicational skills. And they use the Dasher to communicate with the robot. The robot can help them verbalize what they're saying, but also respond intelligently what they're saying via AAC, including Dasher. I will do lots of work on location-based services to develop really important navigational skills for people with a whole wide range of disabilities on Android. This is the Android project I was talking about. It's incredibly important for our target audience to develop travel skills and have the confidence to learn new routes. Spatial skills, as you all probably know, is your ability to identify your current position relative to where you need to get to, and showing users with spatial problems their exact location of a map on a map relative to where they need to get to helps students who have poor spatial skills. Local researchers, however, have shown, we were thinking, shall we develop a route guidance system? People shouting no, because route guidance systems suppress cognitive map development. If you already have very low spatial skills, we don't want to further suppress this. So what we're developing is a system which is a route learning system to allow people to assimilate a mental map of the environment they're going to navigate. Lindsay's pressing the slides on very quickly, so I didn't get to the end of that one. However, what we're just trying to say is our solution to this problem, to all these design requirements, is RouteMate, implemented on Android, and it produces an accessible location-based services learning tool for navigational skills combined with games-based learning approaches. It has 3 phases. In the plan phase, you work on a console to set your start and your endpoints, key landmarks along the way, your estimated time for arrival. In the practice mode, you go out in the community, you use the device to learn this new route, to develop these spatial skills. And then in the usage mode, a lot of the help the phone offers disappears because by then you've learned the route. This is a bit dangerous to be looking down at a phone when you're trying to cross a road, and or there might be other people around trying to steal the phone off you. We've done within subjects evaluation of this, getting back to evaluation again, and we looked at the amount of errors and help needed in each of the phases, and we found there was less errors and less help needed in the usage phase, i.e. the system's working. And we're now streamlining this application to make it much more logical and reduce the cognitive load on for its independent use with people with intellectual disabilities, and make it more accessible for a wider range of disabilities. And it's just very much like cognitive apprenticeship. Early on, you're offered lots of help from the system, working with teachers in this triad of using assistive technology in a context-aware environment. Later on, you're using it more independently. Okay, I'm handing over now to Lindsay, who now will finish the rest of the seminar.
We also believe that these spatial skills are important for people who are blind. Generally, they just learn sequential routes, which are very difficult and effortful to learn, and they require a lot of support. What we've done is there is evidence that using more map-based strategies are more effective for people who are blind, and we've done several studies to try and look at how we can support this. The virtual cane involves people who are blind exploring a virtual environment using the Wii Remote and the Wii Nunchuck. They can explore the whole of the virtual environment. They get auditory, visual and haptic feedback, including ambient sonar. So they can explore an environment. They may know a route through it. If they know a route through it, they know very little else about that environment. They can explore the environment, so perhaps this will help them learn a route through it. If they know a route through it, it will give them more knowledge of the space and perhaps make them more confident, and also make them less dependent on trainers. One aspect of this is that virtual versions of many areas are becoming more readily available. So it's quite possible they could use this interface to explore a lot of spaces to help them when they're trying to learn to move through those spaces. In this case, for the virtual cane, we evaluated the virtual cane. A number of participants explored a virtual environment. They were then asked to describe that environment and then to find some objects in the real version of that environment. And the results we obtained supported the idea that they could create a spatial mental model of that area, and they could use that to construct navigational strategies. We are continuing research on that to look at other compare devices and do a more large-scale evaluation. The virtual cane is designed for, but isn't restricted to, indoors. But for the outdoors, there are a lot of different kinds of GPS and map-based apps. As part of Aegis, we have done carried out usability evaluations of haptic maps, touch over map, and point nav. Got that the wrong way there. These are apps which are accessible for blind people. And we want to see if they can support blind people creating spatial mental models of outside to similarly support their independent travel. Spatial mental models are external frames of reference and map-based strategies so that people have more knowledge about the places they're moving through, so that if they meet an obstruction, they can take an alternative, they could perhaps make shortcuts, they could perhaps go somewhere else than they originally planned. And we hope that the active exploration of virtual worlds and accessible maps will support them in this. One of the advantages of these kinds of systems is that they can use them at leisure whenever they want to. They can spend a lot of time exploring them, unlike their access to real-world support, which is extremely limited, particularly in the current economic climate. Haptic RIA maps, where partially sighted and blind users explore a web-based street map using force feedback device. They get haptic feedback and auditory cues with a sonification mechanism which provides some distance information. So we did the usability studies, but can this system provide information equivalent to that provided to sighted users by conventional 2D maps? In the Aegis user evaluation, we found that people could use the system using a phantom device, but this device is very expensive. A cheaper device was used called Falcon, but that was very difficult to use. Very few people could successfully use that device. This application has a lot of potential. It uses OpenStreetMaps. It's open source. It could be very easily available. So we have suggested a more affordable device, and work is ongoing to see if this device can be used. It would also give a better mapping between the action the user takes and the map itself. This is a device which suggested Microsoft Touch Explorer mouse. Touch over Maps is a phone-based app, but again based on OpenStreetMaps, where people get vibratory feedback from moving their fingers over the roads. They also get street names. They get some basic frame of reference. Additional information can be added to this map. We tried it with 2 blind users who found it very easy to use, and they could easily study the map and reproduce it. One blind user with residual information, there were some gaps in the information and she found it a bit frustrating, but the blind user was completely blind, didn't notice these gaps and found it very useful. This is available for both tablet and mobile. Point Nav is a phone application whereby you can enter particular points of interest and it will then guide you to those points of interest. It can be used, we're suggesting, in conjunction with the map, so that having studied the map, you can decide which points of interest you would like located, and then you could use this to help support you find your way through streets that you've studied in touch over. We are currently about to undertake a study where we use a range of different apps, some of which give global reference information, such as touch over map and haptic maps, some of which support global reference information, such as Point Nav. I keep getting that the wrong way around, sorry about that. Then we have some route-based guidance systems, and then a dedicated route guidance system called Tracker. What we're looking to see is how useful the route-based apps can be and how much extra help is given when people have a spatial mental model of the area. So we're going to see if these spatial apps can be effective in producing a spatial mental model. So can users study those and recreate the map and describe routes from different perspectives? And can this information then support them in dealing with obstacles in a real world route, in extending a known route, and possibly in creating a new route? For this study, one of our blind participants has moved to a new address and knows no routes around that address. So we're going to look at studying various different maps, using various different apps to try and support her and another blind user to find routes around that area and to establish whether or not they can develop spatial mental models.
Okay, so just very quickly conclusions, because I think we're bang on time. So a big approach is user-sensitive, inclusive design, designing on AT using technology that's already popular and widespread use, extending its application to people with disabilities, specifically not to mark them out as being other or different. This may help address the high level of abandonment of assistive technology. In one survey running at around just under 30%. We really like combining games-based learning approaches, novel interfaces, location-based services with navigational support. Accessibility, obviously, is the prime goal of us all. And looking at situational disability as well. And with new digital competencies, safeguarding is even more important when we're looking at, we have students in our school for people with intellectual disabilities getting onto massively multiplayer online games, online chat rooms, having the digital skills doing that, but doing it without the knowledge of their teachers or their parents and caregivers. This makes that we need to celebrate those digital skills and at the same time protect the very vulnerable in this situation. Okay, thank you.
Thank you.
Fine.
Thank you to David and Lindsay. I would like to ask the participants if there is So we got some minutes if you have questions, and there's no problem for that. So please raise your hands while you think. If there is no question, there is Renzo near who's got a question. So I pass the microphone to him.
Hi, everybody. I have a question for Lindsay. When you spoke about the web-based navigation, you spoke about a kind of haptic mouse. How does it work? How does it give a kinetic perception?
That haptic mouse just vibrates. So it could mimic the touch over map in that it, as you move along the road, it would vibrate.
Okay, but is it a common device you can you find everywhere? Is it expensive?
It's about £30 and you can get it off Amazon.
Whoa.
And it's Vulcan device is a couple of £100. So we're really talking about a major league difference. It comes with an SDK. I have asked the developers of haptic maps to have a look and see it would be able to detect the ridges in the map.
Lindsay, is there any other question while I'm uploading the next presentation? You were very clear in explaining, so I think there are no other questions. Well, thank you. Now it's the turn of Warren Goodland from the Disabled Living Foundation. So I think that Warren didn't succeed in entering the Adobe platform with his own name. So Zaid, if you see the name Zaid on the participant list of Warren with his colleague Zaid.
Hello, can you hear us?
Yeah, maybe you can switch a little bit. You can just turn higher your microphone.
Okay. Is that any louder?
Yeah, now it's excellent. So
Okay. And just before we start, Chris Shaw, the CEO for DLF, will just introduce the first couple of slides. Just handing her the microphone.
okay, Warren, I think you can start if everything is okay with your presentation.
Yep. Chris Shaw is just coming to introduce the presentation.
So now I give the floor to Warren Goodland from Disabled Living Foundation.
Hello, it's Chris Shaw here from the Disabled Living Foundation. I'm just going to introduce a few brief remarks and then hand over to Warren Goodland. So this is our presentation from Disabled Living Foundation, and for the webinar. Okay, just a few opening remarks about us, the Disabled Living Foundation. We're a national charity, a not-for-profit organisation, and in the UK we're the leading national provider for impartial advice, information and training in assistive technology. Our offices and equipment centre based here in northwest London are central and accessible to people throughout London and beyond. We have been going for 40 years, so we during that time have acquired a lot of knowledge and information that we get out to as many people as possible so they can benefit and make good decisions about their daily lives and things that can help them. We reach hundreds of thousands of people each year through our websites, our helpline, and through the equipment demonstration centre here. So just by way of illustration, our visitors to our combined websites are reaching nearly a million people a year. Our helpline responds to approximately 25,000 inquiries per year. And face-to-face equipment demonstration, we see in the region of 2,000 to 2,500 people per year. So that just gives you an idea of the scale and scope. This now, the slide now on the screen illustrates the how things fit together a bit. So obviously everything comes from our core data, DLF data, and Warren's going to talk about this and take you through that just very shortly now. So we have, that's our core information that we've spent these 40 years building up, but we can make that information and advice available through a number of channels to people. So through website developments, which is what we've been spending a great portion of the last 3 years doing. Our websites, again, Warren will demonstrate these in more detail, but Living Made Easy and Sarah, as well as our contribution to the Eastern site and portal as well. We have a DLF website separately to those as well, which has information about our charity and the work we do. We publish fact sheets. We host the You're Able forum for people's individual dialogue and comments. We demonstrate equipment here, answering questions through the helpline, as I've just said. And we have a training program which provides both health and social care staff and individual family members who assist older and disabled people with knowledge and skills to help them do the best job in supporting members of the community. We also manage and stage a big conference each year, which is, in fact, we did just last week, which is Moving and Handling People. And this comprises a conference program, exhibition, so that people can see new equipment as it comes on the market and sometimes before it comes on the market, and at the same time receive training and assist their continuous professional development. Okay, that's my introduction really, so I'm going to hand over at this point to Warren to take us through this in detail.
Hello everyone. Can you hear me okay on the microphone? Yeah, a few hands raised. So I'm now going to talk about the database, which feeds a number of our websites. Made Easy, Ask Sora, DLF Data, and then some of the feed goes through to the Easton website that we were looking at last week. There's over 12,000 current products on the database. Plus, we keep an archive of all the previous products that users can look up if they so wish, on products that are no longer available. There's over 33,000 product supplier records on the database, because each product might have more than one supplier, an average of 3 suppliers per product, but some products on the database might have 30 or 40 suppliers that we're aware of in the UK. We keep a list of local retailers throughout the United Kingdom and a list of national organisations, charities, and bodies. So, of those websites, the first one I'm going to talk about is DLF Data. The DLF Data website is intended for health professionals. The full range of the 12,000 products and 1,700 national suppliers are available. Users can create reports listing specific products, suppliers, and either email them or print them for a service user. Users can compare products side by side and look products up on dimension tables. We add MHRA, that's Medical Health Regulatory Authority, alerts and field safety notices to products as they are received. This might be, for example, that a product has had new set of instructions issued, or that there's a warning over a particular part and it needs replacing. And so users should contact the manufacturer. But users of the database will know because we highlight it on the homepage, which I'll show you in a minute. Users can add product comments to a record about a particular product, sharing their experience or asking a question from other users. And users can browse the database using ISO 9999, the 2011 version that we all got working last week. So here's the home page of DLF Data. You can see the main product groups across the top in the menu bar. The MHRA alerts, the last three. One that we've added this week about a mattress, and you can see the latest products that have been added by our data services team. Now this is a sample of one of the reports that you can make on data. So when you're on a product record, you can select to add it to a report, and once you're done, it might only be 1 or 2 products, or it might be a dozen. You can then go to your, they're all listed, and you can print that off, or that you can see the box that you can give someone so that they can then get back to that report, have all the details, contact take it further. Sarah. One of our public websites. Guided advice tool. Really designed if the user isn't entirely sure of the equipment or advice that they're looking for, they can choose from a list. We ask a short series of questions, and depending on the answer to those questions, the website provides a report. Questions of other organisations and signposting, and of that might help and where to get them. Now, going to see this is of Sarah, and here's some of the topics split into sections: health and home, daily activities, and click on one of the topics, then it's the questions. Here's an example from the taking a bath section. Oh, I've lost the I think I've moved the cursor too far. So you can see from the screen, number of there we go. Sorry about that. The options to the next here's another question. The width for the rims on the bath over a certain amount. User of the website can select or the questions. The last question in the question stream is about the location of, because many areas of the UK have licensed versions of Sarah, that we can add extra local information location of that might be relevant to them. If the area they're living in is listed, just go to the national. So here's a from a report. So it shows the question, the user said yes, they difficulty in or out of their bath, and then some not just dependent on question, but on the answer in the questions for further information, and then there's links to certain categories of equipment such as bath boards, subdivisions of equipment. With another question about difficulty standing from sitting in the bath. Example of advice and product groups, and further down towards the bottom, you can see some advice and bath lifts. It's not just advice about products, there's also general advice and warnings included in the report, like this one about water temperature and the risk of scald. Okay. You saw at the end of the question stream that you could choose which area of the UK you were in. And here's an example of one of the licensed versions of our SARA, as well as the customized advice. We customize the design and the look for so that it's relevant to that local authority's own website. It mirrors their website, the colour scheme on this example from Cambridgeshire. Here's another example of a licensed version of our SARA that we've produced with AT Dementia. They wrote and produced the advice, and we've worked the advice into the SARA format with the question streams and coming to the report like you saw earlier. And then next website, Living Made Easy. Again, this is a public website. Everything is arranged into categories. So if the user has some idea of what they're looking for, maybe in the clothing and footwear section or in the leisure section, this is the home page, and they can navigate through to the section that they think relevant to their needs. We can see the latest products and questions from the forum as well on the home page. And this is a page within Living Made Easy to do with toileting, and it shows further subcategories that you can break down to get to the product range that you might be looking for. But it also shows all the advice that we've added targeted at end users. So these links will take you to advice, for example, on bath boards, bath lifts, toilet height, for example, which we'll look at on the next. So here's an example advice page, one about the toilet height. Okay. Now now moving on to the self-service system. So as you've seen our websites, I'm trying to now explain how we keep the information on them to date. So as whereas our data services team that contact manufacturers and suppliers for the latest information. Suppliers can update the information themselves using our self-serve system. This page shows how they update their company details, and then all the address and phone number, the contact person for particular products, web addresses, and so on. When it comes to the actual product information, suppliers can amend the name, the price, and availability of the database. If they're a manufactured product, they can add a manufacturer description. They can update the web address on their website, a product-specific web address. They can add a manual or a YouTube video, and they can add multiple images for each product. Suppliers can also search for and link themselves to other products on the database that they supply, and they can add new products that they sell that are not already on DLF data, and then we will process and categorize them. Here's an example from Living Made Easy of a product with multiple suppliers, and I'm showing this slide because to talk about the order in which the product suppliers are listed. There'd be issues if we were to order them alphabetically. That wouldn't be fair to suppliers that had names further down in the alphabet. We've developed a system that looks at a number of factors about the supplier, such as the amount of information they've provided, and pictures, their membership of trade organisations like the BHTA, the British Healthcare Trades Association, where members have signed up to a code of conduct designed to protect the end user, and of how frequently or how recently they've updated the information using self-serve. So all that is calculated and determines this rating system, which determines their order on the list of product suppliers. The DH Information Standard is a certification scheme for health and social care information producers in the UK. It's in its third year now, and the DF was a founder member of the Information Standard. Members of the scheme must follow consistent, rigorous procedures when producing information for the public, and are audited each year to ensure they comply. So, for example, it govern the process when researching information, that there's thorough research of evidence-based materials, and that when the material is written, it's peer reviewed and user tested, and that there's consistent processes in place to ensure this. So consequently, someone reading our advice or another member of the scheme's advice, if they see the information standard on the leaflet or on the website, then it helps them, gives them confidence that the information they're reading is trustworthy and from a reliable source. Right. The helpline. Our helpline receives approximately 1,800 calls per month. Helpline staff give advice over the phone, and they post fact sheets and reports from dealer data.
we can hear you. Yes, it's quite good. Okay, thank you. But um, I'm wondering if your presentation is finished. Okay. Thank you very much to all the staff of DLS for your interesting presentation. Now, I would like to know if there is the wishing to ask a question to DLF. While you are thinking, okay, so there is Evertian who raised his hand. So